Hi, this is Mr. Max. So I am doing the second part of my three-part videos or series on the inverse functions, trig functions, and today I'm looking at the cosine function. Right, so remember the graph of the cosine function. If you have sketched it by now, you should be very familiar with it. Again, it's a repeated wave. It goes on and on and on. So we call them periodic. Okay, so we're going to deal with the inverse of the cosine function. So if we have a horizontal line test, and we do this when we want to test whether a function will be a one-to-one function or whether the inverse of the function will be a function. And in this case, you will see that it cuts at numerous places. So the inverse of this particular function is not a function. So we need to restrict the domain so that we can then only work with that conventional part. Okay, so that is what we're going to look at in a nutshell. So this is the conventional interval that is used when we are dealing with the cosine function. So we are only working with the principal interval of 0 to 180 degrees or 0 radians to pi radians. So this is the part of that graph, so to speak, that you have seen in the previous slide. This is the graph, the part of it that we use conventionally when we deal with the cosine function. All right, and we are going to look for answers in the first and in the second quadrant. And it's very important that you do realize, if you are used to the Cos diagram, that the cosine is positive in the fourth quadrant and positive in the first quadrant. So in the second quadrant, the ratio would be negative, so you can see like negative 0.4 will be somewhere here, and that angle will be slightly be 114 degrees. Okay, so it's very important that you do understand, and the range is between -1 and 1. Right, so we're going to have a look and see how, if we do the inverse of this particular part, how it would look. So it's very easy. You will realize that there's going to be a line that you can draw if you want to do it, the line y equals to x, and then you just swap the points around. I like to take, like say, take this particular graph and then I just turn it anti-clockwise. Well, then you will see how the inverse function would look like. Also, something worth remembering, that sometimes we write arc cosine of x. It's exactly the same as the inverse of cos, which is written sometimes as that. Please don't confuse this as 1 over cos x. That is something else. That is the second of x. So it's just the same notation. Right. So again, this is how the graph will look like when the domain is restricted and you are drawing the inverse. So you see that now the values of x becomes values of y, and the values of y becomes the values of x. So it's like they're swapping around. And the range, you can see, is now from 0 degrees to 180 degrees, or 0 radians to pi radians. And the domain is between -1 and 1. So this is what we're going to work in essentially. Right, so again, you have got special angles that you need to know, and we're going to take them from two types of triangle, the 45-45 90-degree triangle, or the isosceles triangle, and the other one is 30, the 60, the 90-degree triangle. So when you are doing this, and suppose you say this distance here is 1 unit, then obviously this distance here will be 1 unit as well. And if you have the two sides equal, then these two angles here will be equal. Base angles of an isosceles triangle are equal. So these angles are complementary, or they are sharing another 90, because this is 90 already. So that's 45 degrees, or you can say pi upon 4 radians. Right, so when you use Pythagoras, you can actually calculate the hypotenuse. In this particular case, it's going to be √2. Another one that you can obviously now, if you want to work out the cosine of 45 degrees, then you realize it's just going to be that opposite, because that's the cosine, is the the adjacent, which is 1 here, divided by the hypotenuse. And it will give you the same if you take the other angle on top there. The adjacent is 1 upon root 2, or root 2 upon 2 if you want to rationalize the denominator. Then we have the 30 degrees, 60 degree, 90 degree equilateral triangle. So if I drop a perpendicular here, then I'm going to divide this here by 1. This is going to be 1, 1, but I'm not just interested in one part of that. Again, you can realize that we can create a few things. We can actually calculate the height of the triangle here. Using Pythagoras, you'll find that it's root 3. So you can actually calculate the cosine of 30 and the cosine of 60 degrees. The cosine of 30 degrees is going to be adjacent over the hypotenuse, which is root 3 over 2, or the cosine of 60 degrees is going to be 1 upon 2. Okay, so these are just the two diagrams basically that you need to always remember. And if you remember these diagrams, you should be able to solve questions where they ask you to use special angles, and they are referring to these angles here, the 45 degrees, the 60 degrees, and the 30 degrees. So I have here some exercises that I want you to try on your own. You can pause the video and do not use a calculator, and when you make sure your calculator or your answers that you're giving rather, if you give your answers in degrees, then make sure you give them in degrees. If they're in radians, give them in radians. In this particular case, when I do this, I'm going to use both. So pause the video and attempt to solve the questions on your own. You realize that part E is slightly different. And I'm also bringing up this very important hint for you that you should always remember as far as the cosine is concerned, that we are dealing with in the first and the second quadrant. And the sine, because I've got something here of arcsine, is also going to be dealt with in the first and in the fourth quadrant. And this table here is also a very good table that can sort of summarize when you're dealing with these particular questions. Arcsine of y equals to x. You can just write what it means. It means nothing but sine of x is equal to y for that particular interval. And cosine of y equals to x means cosine of x is equal to y for the interval 0 to 180 degrees. But when you do arctangent of y, which you can say equal to x, is the same as tan x is equal to y, and the interval is between minus 90 degrees and 90 degrees, not included or inclusive. Right, we're going to look at the next video. We're going to look at tangent in detail. Alright, so let's see. Perhaps you have attempted to solve this question. So the first thing I would like to do is I would like to just write down what this arc cosine is. I'm writing that with a -1 there. It's still the same thing. You don't have to do that. But this is the important part. Always say equal to x. And from here, you can now actually say, what does it actually mean? So it means nothing but cosine of x is equal to -1. So in particular, that is like the cosine is the adjacent over the hypotenuse. So the adjacent will be -1 over 1. Okay, so which is basically something like this. And of course, it's negative and it's going to be in the second quadrant. All right, remember I said when we are dealing the cosine, we are going to use the first and the second quadrant because it's between 0 and 180 degrees. And since we have a negative ratio here of a negative value, we are going to have to deal with where cosine is negative, namely in the second quadrant. Right, you don't have to use Pythagoras, but in this particular case, I'm using Pythagoras to find that y value is kind of very interesting here. So what it actually means, think of an angle that goes from here, but then it doesn't have any vertical distance. It has got it goes to the left, it has a horizontal distance, okay? So it's a line that starts from here and then it's directly on top of that. So this is a very interesting case. And that angle that will move like that is nothing but 180 degrees, okay? Because it doesn't have a vertical distance. So it's like this one here, this radius, if you can say, is the same distance as this value here, the x distance here, So in that particular case, the angle is 180 degrees. We can't consider 0 because we said in which quadrant is cosine negative. All right, this is another interesting one. Again, what I like to do is I just like to write everything to equal to x. From there, what does it actually mean? So it means the cosine of x equals to that. And of course, you're going to use your special triangles. You're not going to use Pythagoras every time. So the cosine is the adjacent, which is negative 3 upon 2, the hypotenuse. So when you look at your triangle, which particular triangle fits this? And of course, it must be the 60, 30, 90 degree triangle because the hypotenuse is 2. All right, you have got that negative 3, which is adjacent to that particular angle. All right, so from here we can actually find our calculation. We can also realize that our answer will be in the second quadrant. So whatever the angle is, it's 30 degrees because 30 degrees is adjacent over hypotenuse or pi upon 6. But our solution should be in the second quadrant. So therefore it's 180 minus the 30 degrees, which is 150, or pi radians minus pi upon 6, which is the same as 5 over 6 pi. The other two, again, I've drawn the diagrams for you, and you can also see the quadrants. Okay, so I always write down equals to x. I always advise you to do that. So when you have arc cosine, arc sine, arc tangent of something equal, let it always equal to x. And from there, you just write down what actually it means. It means that the cosine of x is equal to 1/2, and this means the opposite or the adjacent is 1, and the hypotenuse is 2. So if I bring those values in here, now I have to go back to my special triangles, which you should know. And you should know that you are dealing with the 30, 60, 90 degree triangle. And in a particular case where you have the opposite to be 1 or the adjacent to be 1 and the hypotenuse to be 2, we're talking about this 60 degree triangle or angle here. So our answer is pi upon 3 radius or 60 degrees. It's relatively easily if you know what you're doing. Right, second instance again, let that stuff equal to x. Then what does it mean? It means cosine of x is equal to negative 1 over root 2. Again, so I know that I have to deal with in the second quadrant because cosine is negative in the second quadrant. So whatever angle I'm going to now use from my special angles or special triangles here, I am going to also know that I must subtract 180 minus that angle. All right, so looking at these two, the only place where you have the hypotenuse of root 2 is the 45, 45, 90 degree triangle. And cosine is adjacent over hypotenuse. So the answer would just be, the angle should be pi upon 4 or 45 degrees. But our solution is nothing but that 45 subtracted from 180, which is 45 subtracted from 180 gives you 135 degrees, or 3/4 of pi if you are giving your answer in radians. All right, so the last one here that I have is arc sine of that stuff cos of pi upon 4 or cosine of 45 degrees. So what you do is you again just remember that sine is from minus 90 to 90 and cosine is from 0 to 180, and also that the sine values are in the first and fourth quadrants. That's where we are looking for the solution. And well, you can go ahead. I'm just rewriting arc sine as with a negative 1 here. It's easier for me, but you can write here arc sine. The important thing is you let it equal to x. And what does that mean? So it means that the sine of x is equal to what you have here. Now, cos of pi upon 4, you can now use your special angles. And when you use your special angles, you realize that the ratio that we are looking for is 1 over root 2. So that cos of pi upon 4 is replaced by 1 over root 2. Now this brings us now to where sine is positive, and sine is positive in the first quadrant, and we also have a solution for it in the fourth quadrant, but it's positive in the first quadrant. So that means what we have now is we have a triangle something like this here. Again, you don't have to use Pythagoras here because you're supposed to use your special triangles here in order for you to find that particular angle. And the one that has got the root 2 is the one of the 45, 45, 90 degree. Therefore, using that, we realize that the value of x should be pi upon 4 or nothing but 45 degrees. It looked a bit difficult, but it was not really that difficult. So please remember, stay tuned and have a look at the third one, which is the inverse trig function for the tangent.